we have here? The first question. You all see it? All right. It says, determine the amplitude and phase shift of the following function. X minus pi over 3. So the amplitude. The amplitude refer to?
The one that does the compress, or
it does, but it pretty much looks for height.
height.
In the sine function, in just the basic sine function, what does it look like? When x is 0, what's the sine of 0? No, it's going to be a sinusoidal wave. It's going to be a curve. But is it going through the origin, or does it start at
Origin.
How many of y'all remember your trig, the reasons, the whole thing behind trigonometry? When you look at the unit circle, each point on your unit circle is bounded by 1 and negative 1. Each point on the unit circle is made up of an x and y component. But more than that, the x components are represented by the x component, or the sine cosine components, and the y's values are the sine components. So, at 0 degrees, or this is what x, when x is 0, sine of 0 is 0, because this point here is 1, 0. But 0. At pi over 2, it's this one. It's this one. This is pi over 2. What's the location there?
0.
So the sine value is 1. At pi, it's back to being 0. At 3 pi over 2, it's now at 0, negative 1. And then it completes the cycle back over here, which is, so the sine function we know looks like this. What's the amplitude? How high does it go? 1. Shift is the horizontal shift. What is it telling us to do? In which direction do we go? How far do we go? To the right, pi over 3 units. So we have to go. So now our graph shifts pi over 3 units. So if we look at our possible choices, this is a vertical shift. That's not right. This is just, it's on the wrong side. This is the wrong side. So the answer is A. So the amplitude is 1 pi over 3, and it's A. It's shifted to the left, pi over 3 units. Let's look at question number 2. Yeah, we'll go through a whole review of trigonometry later on. Just because when we get to those parts, those are pretty important for us. Finally, simplify each of the following for f of x equals 5x minus 2. So it's asking us to find f of x plus h, f of x plus h minus f of x, f of x plus h. We have to do these three things. Does anybody remember what this is called from algebra? I'll give you the initials. Very good. I was going to put the hangman's up there, but yes. It's the difference quotient. That's going to be our starting point for the calculus part. So the first part, we have to find f of x plus h. So we go to our function. Anywhere we see an x, we put an x plus h. That's what it tells us. Anywhere we see an x, we just put an x plus h. F of x plus h minus f of x. It's 5x plus h minus 2 minus f of x is the original function. Is that right? That's all it's asking us to do is put that together. We eventually will, yeah, but there's something I left off by mistake, by intention actually. Parentheses. Whenever you have a negative, a subtraction, whatever you put behind it, always put in parentheses first. Because if you didn't, the only thing that becomes negative is that first term. Let's go ahead and simplify this one then. Let's go ahead and simplify this one. Throw it out and everything. So we have 5 times x is 5x. 5 times h is 5h minus 2. Negative times positive is negative 5x. Negative negative is a positive 2. Quotient, everything after the minus sign has to disappear. And sure enough it will. Negative 5 and 5, positive 2 and 2, so we just have 5h. And the last part says, take what you just did and divide by h. There's your answer. X plus h minus 2, 5h, 5. We'll come back to this next week when we talk about how it relates to calculus. What it means. Divide and simplify. 14x to the power negative 20, y to the power 9, 38x to the 16th, y to the 2nd. What are the rules of exponents? What does a negative exponent tell us? Yeah. Negative exponents are simply rewritten as the reciprocal of a positive exponent. It doesn't change the sign of the function, it just changes the sign of the exponent. So, this, it goes on the bottom, becomes positive. Positive, that's positive. $14 and $38. Do they have anything in common? 14 and 38? They have a 2 in common. 2 goes into 14 7 times. 2 goes into 38 19 times. Okay. Now on the bottom, we have 2 x's. What do we do with the exponents? Add them. The rule here is when you have the same bases, add the exponents. So 20 plus 16 is 36. If you have same bases top and bottom, then you take the larger minus the smaller. Since the larger is on top, we subtract them from on top. 9 minus 2. So your final answer, y to the 7th x over 36. Number 4. Express in terms of sum and differences of logarithms. Log radical b to the 4th c. Well, what do we have to do there first? First thing we have to do is get rid of the radical. So the radical x becomes the conversion from radicals to exponents is that. Whatever the root is goes on the bottom, whatever the exponent is goes on top. Okay, so what properties do we have about logarithms and powers? Whenever you have an exponent, it becomes a front. Log x to the power n is n log x. So we have 1/2 log b to the 4th c. Are we done?
No.
Why not? What do we do here? What do we do with these? We have product of 2 terms. The product of two terms becomes the sum of the two logs. Oh no, because we still have an exponent here.
Yeah, I was gonna say bring it to the side.
So it has to come in front. And distribute to get rid of the parentheses. 1/2 times 4 is 2. 1/2 times 1 is 1/2. There's our answer there. Two log B plus 1/2 log C. All right, the next one. That f of x equals negative 5x minus 1, g of x equals x squared plus 5, and h of x equals x plus 4 divided by 3. Find h of g of f of 1. What does this mean? Right. It's a composite function. So what this means is that f of g, here's the rule, means that f of g of x. So it goes from right to left. The function of g goes inside f. So f goes in g, g goes in h. So how do we want to do this? What this is really asking us to do is this. Asking us to find that. Here's one. We find f of 1 first, and then we do what with it? What do we do with this value?
Oh, we just we put in just G.
Now it goes inside g. So g gets negative 6. Negative 6 squared is 36. And lastly, this value goes in h. .45 divided by 5 is 9. There's your answer. Mm-hmm. Convert the following radian measures to degree measures. So what's 2 pi? 360. Write using radical notation. (36x squared to the power negative half) 6x to the power negative 1/9. So it says, write using radical notation. What does radical notation mean? What is a radical? That's a radical. So I want you to put the answers into some kind of square root form. Or nth root, I should say. So let's look at the first one. Do first with all this. Put up inside there? Put the whole thing. The whole thing goes to the bottom. So 36x squared now becomes positive 1/2. What about the bottom? So what goes on top?
1.
Just 1?
No,
The 6 stays on the bottom. Why? Where is the exponent connected to? Is it connected to the 6 or the x?
Yes.
X only, because this is 6 times x to the power negative 1/9. There's no parentheses, so the 6 is separated from the exponent. All of the negative, it says it goes on the other side of the dividing line. If it reciprocates.
Oh, reciprocate. That's the one. Okay, got it.
What do we do with this 1/2 power here? We can simplify this down here.
Put it to where the 6 is.
What does 1/2 mean?
Oh.
Square root. So let's look at what we have here. The square root of 36 is what?
6.
The square root of x squared is?
X.
Six times 6 is 36. Are we done?
No.
Why not? What do we do at the top?
Make it a radical.
How do we make it a radical? What does it become?
Square root of x.
This is 1/9.
I mean, no. 9 roots.
9th root of x to the first. There's your answer. Good. There's a whole bunch of trig ones here, which I'll wait till next week to do. Because it's having us convert to from radians again. Okay. Find the exact value of this.
X and Y value?
And it says find the exact value for that.
Oh, does it require calculator?
What does this mean here? How would you read that? Cosine. So basically what you're looking for, what you're looking for here is this. Is what theta, or what angle of cosine would give you that value? Square root of 3 over 2. It's negative, so it goes in the fourth quadrant. Or, since cosine is to the left, second and third. Remember, cosine is on the x-axis. For it to be negative, we're looking for an answer over here. So what angle of cosine gives you radical 3 over 2?
The second quadrant? I know, like third.
Not quite. I'm looking for a quadrant. I'm looking for an angle. Pi over 3, pi over 4, pi over 6. Because it is negative, so it has to go in, it's in the second and third quadrants. Nine. Okay, this one is a lengthy one. Let's do with transformations. All right. The graph of the function g is formed by applying the indicated sequence of transformations. Find the equation for the function g and choose the correct graph. The graph of f of x is the cube root of x. Shifted 4 is left to let's look at this, we have to graph this eventually. So what does this graph look like?
Oh, no, wait, what about, no, that's,
Let's look at, can x be negative?
no, yeah,
It's an odd root, so yes.
oh, yes,
Can x be 0?
no,
Yes.
oh, yes,
Cube root of 0, 0. So we know we can do the entire domain of x. So you're going to
yeah,
decide exactly.
oh,
Yes. So that's the first one. So now what do we do?
we,
Shift it 4 units left. Exactly. Since it's going to the left, we add 4 to it. Why do we add it inside the function?
because, adding, I mean, it's going negative.
No, it's inside the function. We add it inside the function because that's the horizontal shift.
Oh, right.
Anything happens inside the function is horizontal, the constriction and everything, and everything happens outside is vertical. You got a question?
No.
Okay. And then 2 units up.
Plus.
Where?
Outside of the.
Outside of the, yeah.
Because like you said, vertical shift.
So there's your function. And the graph is going to look like, because it moved 4 units to the left. There's the new origin. And it goes up 2 spaces. This is my new origin, so the graph looks the same. It just, yeah, it's, all I did was shift it from here, 4 units left, 2 units up, so the whole thing moved over. Which graph do you think it is?
It's D.
D.
D is correct.
Number 10. Rationalize the denominator. How do we rationalize? What does that mean, rationalize the denominator? Get what? You cannot have a radical on the bottom. Yeah, so it's that you get rid of the radical, move it on top somehow. So this is what we have right now. We have cube root of 10 over the cube root of 3. You can leave it that, or you can convert it to exponents. In other words, what the bottom needs, we need to have an exponent of 1 on the bottom. What does it need to get an exponent of 1? So we have to have, how many more 3's do we need? We have 1, how many more do we need? We need to have 2 more. So we multiply top and bottom by 3 to the power 2/3. So on the bottom we have 1/3 plus 2/3 is 3/3, which is 1. So it's rationalized. So on top, what do we have? No, we have 10 and then 3 squared. Any questions so far? Our entire objective is to get rid of the radical on the bottom. Yes? Yeah, I suppose the rule of math is you cannot have a radical on the bottom. So, yeah, I have to look at that because that's somebody else said that they had their answer they even said rationalize. The whole purpose of rationalization is to get rid of the radical on the bottom. So I don't know why it did that. So yeah, I have to make a list of all the ones that are wrong and start giving those points back, because that's not good. Thanks, Patrick. Okay, the next one. Use the graph of f of x equals log base 2 of x to graph the function. So what's happening with this graph? Where?
One to the left on the negative.
Very good. So if we look at the original function, that's the logarithmic equation. If we shift it over one to the left, it now shifts, goes to there. So that means at -1, we have our asymptote. Yes?
I forgot what, I know I've heard of it before, but what does asymptote mean?
Asymptote is a vertical or horizontal line, is a line that the function cannot cross. It can approach infinitely, but never touch.
Oh, okay. Okay, I was going to say, it's familiar about saying another going down. Or
Right. Well, remember when we talked about the 1 over x squared function, the Atari function?
Oh, yeah.
It'll never be 0. It'll get infinitely close to it.
Really close.
But yeah, in calculus, when we talk about limits and functions and things like that, we're going to talk about infinitely close, approaching infinitely close to a number or a value.
Is that why they have the, remember we got this like one, like greater less thing, or?
Mhm.
Oh,
Number 12. Use the graph of y equals e to the power x and transform so the function y equals negative e to the x minus 5. Determine the domain and the range of the function also. Also determine the y-intercept of the equation. So we have to have the domain, range, y-intercept, and find the equation of the horizontal asymptote. So what do we know about, what is the basic function here? E to the power x. What does e to the power x look like?
it looks like no, it's the other way around. No.
It's an exponential function, so whenever you have x on the top, can this function ever be negative?
No.
No. Because the only way this function could be negative is if the base was negative. And that, we're going to get to what are called oscillating functions, which are very, very complex. But whenever we talk about exponential functions, we deal with the base being positive. Because if the x is negative, that means it's a fraction. It's very, very close to the x-axis. This is an exponential function. When x is 0, y is 1. So the graph is like this. E to the x. So, but we know that it crosses at that point there. What kind of horizontal shift do we have?
There's none. Oh wait, no, it's.
Yes, no, 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 yes, no. I've answered all your questions. No. As 5. Which direction?
The right. No, wait. No, yeah, right.
Here's x. Horizontal shifts always affect x first, not the function. So, since it's negative, we shift it to the right 5 spaces. 1, 2, 3, 4, 5. So this intercept here is now intercept there. We put a negative in front of it. What happens when we put a negative in front of it?
Compress. I mean, no, flip.
Flip across which axis?
The y-axis.
The x-axis. Because it happens outside the function, it's a shift across the x-axis. So 1, 2, 3, 4, 5. There's that. Shifts there. There's our graph. So what's our domain? It goes from negative infinity to positive infinity. What's our range?
Zero can't be. Zero greater than. Zero.
0, negative infinity.
Right.
Or actually, it should be negative infinity, comma 0. Smaller to larger. Or y is less than 0.
I got a question.
Yes.
So I know it's like 0 infinity, but what does it mean if we have a bracket instead?
If we have brackets, then we can include it. So, for example, the square root function. It starts off at 0. So it starts at 0. I can use 0 because that's a valid value. It goes from there. So the bracket simply means it's inclusive in your data, into your answer set.
So that means it won't move after?
No, it's a value you can use. If it's a parenthesis, you can only get infinitely close to it, but not touch it, not use it. What's the y-intercept? No, it used to be 1, but it shifted over, so it's now down here. Negative something small. Yeah, that's when you use calculators for that one. So horizontal asymptote. The x-axis. Or the value y equals 0. That had a lot of steps in it. Yeah. Number 13. Rewrite the rational with rational exponents. It says rewrite with rational exponents. Basically what it means is, first off, inside the parentheses, power 9, inside here, power is 1 over 13. That's the root. We have a power to a power. You multiply them. 9 times 1 over 13 is 9 over 13. X, 6y, 9 over 13. That's it, yeah. We just wanted that to be a rational exponent. Number 14. Determine if the graph is a function.
Touching twice correct.
What?
The questions as a function. Twice?
Which one?
The vertical.
Is it the vertical or horizontal line test that tests the function?
The vertical.
Or horizontal? These are the two tests that we have. The vertical line test tests for a function. The horizontal line test, see if it's one-to-one. So, is it a function?
Yes.
Yes. Number 15. Write the expression 27 equals 3 to the power 3 in log form. So, given a logarithmic equation, it's called a what? It's called the base. And it remains the base. Because when you convert it to exponential functions, the base pushes the other value up. And if the base is gone, the log drops away, and there you have the x. So whatever's by itself is the x value. The base is the base, and the answer is the exponent. It's log base what?
3. No, 27.
27, because this is the base, has to remain the base, equals 3. So far, everybody okay with this so far? Not as scary now, is it? Number 16. Use a graphing calculator to graph the function. Then visually estimate the domain and range. Actually, do it without a calculator. You pretty much know what it looks like. What do we know about radicals? What can you not have inside there? Negatives. So the smallest number you can have inside there is what? 0. F of x equals radical 64 minus x squared. All we know for sure is this. We want to set the inside because 0, because that's the smallest we can have x. 64 equals x squared, square root both sides. X equals what?
8.
So minus 8, right. Whenever we take a square root of a number x squared, you have to put a plus or minus in front of the solution. Why? Because if x squared equals 4, x can be 2 or negative 2. Negative 2 squared is what? So whenever you have a squared term, it can be a positive or negative answer. So our x is representing what? What's our domain? Because we can't use anything bigger than 8. If we do, it's a negative, and it becomes an imaginary number. So at 8 and negative 8, what happens to the function? 0. So at 8 and negative 8, function is 0. It's a radical. Is it on the above or below the x-axis? Has to be above. So, midpoint, when x is 0, what's the value going to be? What's the square root of 64? So the range is from 0 to 8.
Didn't have the line under the equator.
If it didn't, then I couldn't use it. Then that means the graph would not go to that point.
Oh, okay.
So we know that if x is negative 8 and we plug it in there, the value is 0. That is a valid point in that graph. If x is 8, then we get that point. So it has to be included. Or when x is 0, we know the value is 8. So all of these points have to be included. So what do we have here? Answer is B and D. Because it can equal 0 and it equal 8. They're both included. Number 17. Is the correspondence a function? Based on? Yeah, so you got them right, but there's only two answers instead of both. Which one are you going to stick with? Is it, ladies and gentlemen, is it?
No.
No. Put it no.
Because the x is going to w.
Because, yes. Yeah. Because of the, which test functions?
Vertical. The vertical line test.
Horizontal. The vertical line test, no, horizontal is vertical. So for every one x, you have to have one and only one y. For every one x. The way I described it in my algebra courses, there's no, it's not a happenstance they use the word correspondence here. Because think of what do they call mail back in the old West days? Correspondence. What correspondence did you receive? Correspondence is the official word for mail. So, functions are one-to-one. You have a relationship, or as opposed to association. Can you have a relationship with more than one person?
No.
Can you have acquaintances with more than one person?
No.
Yeah, you can be friends, but that's the difference of functions. A function has to be one-to-one. For every one value of x, you have to have one value of y. So for every one x letter, you only have one y recipient. That would be a correspondence, a one-to-one correspondence. Find the logarithm. Okay, the next one, find the logarithm. Log base 4 of 256. Without a calculator, here's Let's figure this out. So what we know is this equals some answer. So let's convert it. We have 4 to the power x equals 256. Is made up of what? We know that what number goes in there. Ends in an even number, so we know 2 goes in there. 2 goes into 2 once. 2 goes into 5 twice with 1 left over. 2 goes into 16 8 times. 2 goes into 12 6. 2 goes into 8 4. 2. 16. 2 and 8. 2 and 4. 2 and 2. So I prime factorize it. 1, 2, 3, 4, 5, 6, 7, 8. Whenever you're asked to solve a logarithmic equation, and they just give you the number, you have to get the same base. How about this one? What is 4 made up of?
2, 2.
So it's 2 squared to the power x. So it's power to a power you multiply. Since the bases are the same, in order to be equal, the exponents have to be equal. Divide both sides by 2. X equals 4. And there's your answer. Number 19. Graph the following function. So all this one's looking for is transformations. We only have a shift inside there. That makes us say, what kind of shift?
Left shift.
It's a horizontal shift. Right. Since it's a plus, that means we go to the left 5 spaces. So what we have to do first is figure out what does the graph look like. What does the graph look like? Oh. It looks like this. Like that. So what we do here is 1, 2, 3, 4, 5. And there's a shift. So that's the graph. So it's our graph then, it can't be C because that's a vertical shift. It can't be D, that's a short vertical shift. B is in the wrong direction, so the answer has to be A. Okay. Number 20. Express as a single logarithmic entity and simplify. Okay, so what do you do first?
Bring down the exponents.
No, we're trying to simplify. It wants it as a single term.
Oh, right.
So what happens to these coefficients? Right, they become the exponents of these. Now what? We have a subtraction. What does that mean? It becomes a division. Okay, we got it down to one logarithm, but now we have to simplify all this stuff. So we could distribute this to both terms there. So we have 4 to the power 5 over 2, x10 power 5 over 2, same thing here. 2 to the power 2 over 15, so 2 over 5. 2 over 5. Y to the 15 to the power 2 over 5. What's going to happen here? Well, 4 is what? It's 2 squared, isn't it? So we multiply the exponents. So 2's cancel, so this becomes 2 to the 5th. Multiply the exponents, so 10 divided by 2 is 5. 5 times 5 is 25. This one we can't do anything with. 15 divided by 5 is 3. 3 times 2 is 6. Are we done?
No.
Why not?
The 2.
Okay, so we have 2, 5 minus 2 over 5. If you don't remember how to subtract fractions, butterfly method. It's a great thing. I love the butterfly method. So I make that a negative. So it's negative 2, 25. 25 minus 2 is 23 over 5, which makes it 4 3/5. It's 2 to the 4th, 2 to the 3/5. That takes care of that. Two to the 4th is 16. 5th root of 2 cubed. So 25. Y to the 6th. Answer. See if they even have anything. Oh, they left it as radicals. Turds. So 23 over 5, they'll put it as C. We combined both top and bottom, we got C. Because this is where I started off. Then when you combine these two, you get 23 over 5. One. For the function f of x equals 7 minus 9, determine whether f of x is 1 to 1. If so, write the equation of its inverse function in the form f of x equals inverse of f. Graph the functions of f and inverse of f on the same graph, and state the domains. Oh boy, I hate these questions. Basically, what does inverse function mean? Oh yeah, when we find the inverse, what does it mean? So if you had two functions, f of x and f of negative x, the inverse. It says here is the domain of this one is the range of this one, and the range of this one is the domain of this one. That's all it says, tells you. Yeah, the steps to find the inverse, only 2 steps. Which x and y, all for y. That's all it takes to find the inverse. That's how come, because of switching x and y, you've taken the x of the domain of the first one is the range of the second, and the range of the first is the domain of the second. So since our function is 7x minus 9, the first step is switch x and y and solve for y. We have to add 9 first. So the inverse is x plus 9 to the 7. Then it asks for the domain and the range. So the domain of 7x minus 9. What's the domain of this one? Yeah. Negative infinity to positive infinity. What's the range? Linear equations usually always have all the numbers. So that means since the function is defined on everything, there's no holes, so you can't make the bottom equal 0, that means the domain is negative infinity to positive infinity, and the range is negative infinity, positive. That's all it would. Yeah. Yeah, that's basically, once you have the original function and you find the inverse, if it exists, it doesn't always exist. If it exists, then the range is simply the domain of the first. Just flip them. "22." You only have 12 more pages. Find f of g of x, given f of x equals radical 3x, and g of x equals 1 over x. Remember, what this composite function means is f of g of x. What it tells us is take the g function and put it anywhere I see an x inside the f function. Put g of x in its place. That's what this says. So f, the fog, is radical 3 over x. It was 3 times 1 over x, which is 3 over x. What's the domain of this function? Is that what I was asking? Because you cannot have negative inside here. You can't have negative and radical. Can't be 0, so it's only positive numbers. Three. Consider the function y equals absolute value of x and y equals absolute value of x plus 8 minus 4. Sketch the graph of a pair of functions using standard window in the standard window. Describe the transformation. So what does absolute value look like?
It's a V.
It's a V. What does this one do?
It shifts to the left.
How many spaces?
8.
Then where?
And then down 4.
1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So here we have, at this junction, we have our new origin. And since it didn't rotate, that's all we have. So there's our second graph. So shifted to the left 8 units and shifted down 4 units. This stuff was still kind of foggy. Don't worry about it. We'll keep on reviewing as we go through this course. I'm not going to make anything so difficult that'll lose anybody. Which is also why I'm glad we have such a long class, because once we finish the topics, everybody who doesn't understand, everybody who understands can go ahead and leave. Everybody who doesn't understand, we can stay and do some problems. All right? Any questions? Tribes, comments, threats? No? Let's go start your weekend.